So in this section, we're going to talk about the reciprocal trig functions. Now, be careful, don't say the word inverse trig functions. Those are way different and a lot more complicated. The reciprocal trig functions are the inverse ratios, the reciprocated ratios of the three basic trig functions: sine, cosine, and tangent. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Now I know, everybody's like, well, why isn't secant and sine related? It's just not the way it works. They actually come from this, when you draw lines into the triangle, or not the triangle, into the unit circle, the word secant, which means to cut the circle, shows up, and a cosecant is another one of those. Right? In fact, a tangent is actually a tangent line. So, we use the idea of cosecant, we say CSC. Okay. Again, there'll be an angle, so the cosecant of an angle, the secant of an angle, the cotangent of an angle. Now here's the nice thing. If you look at the sine, if it's opposite over hypotenuse, then cosecant is hypotenuse over opposite. Okay. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And similarly, cotangent will be adjacent over the opposite. So, if you want to look at it, there's that. A over O. Ho, ha, A-O. It's like a song. I know it's terrible, but hey, sometimes it's easy to remember. Now, again, just like before, we should be able to figure out the reciprocals. So, the reciprocal functions by looking at the sides and just putting them in. Now the bonus is, if you know the original, you just have to reciprocate. So if you know the tangent, reciprocate it and you get the cotangent. Alright, just like normal, we are going to need the hypotenuse for these sides. So we know that Pythag works here. C squared equals A squared plus B squared. We don't know what C squared is, but 5 squared plus 2 squared, 25 plus 4, C squared equals 29, so that means C equals the square root of 29. Of course, that doesn't break down. Now, what you're going to realize is, unlike when you were looking for secant, or for sine and cosine, hypotenuse is on the top. Well, that's good, because radicals on the top was going to make it easier. So cosecant, if we remember, is the reciprocal of sine. So sine was opposite over hypotenuse, so this is hypotenuse over opposite. The hypotenuse is radical 29. The opposite of angle A, which is across, is 5. Secant goes with cosine. Cosine is adjacent over hypotenuse, so hypotenuse over adjacent. Ho, ha, and if you wanted to, you could say A-O. Say it wrong, you know. So, cotangent. That's later. So, hypotenuse again. That's not what I wanted. Go back. Thank you. Hypotenuse is radical 29. And the adjacent is 2 this time. The opposite here for angle A is 5. Or adjacent, oh my goodness, over 2. Adjacent is 2. While the opposite is 5. So, you can see we can get that. We could construct our sine, cosine, and tangent. We're going to run into a little more problems here because we're going to notice that we have our opposite side that's missing. And 8 squared equals B squared plus 3 squared. 64 equals B squared plus 9er. 53 equals B squared. Square root of 53 equals B. And that does not break down. So we're going to get some nasty action there, because if we use the opposite, we're going to realize we have a radical in the denominator. So, hypotenuse over opposite. 8 over radical 53. So you multiply by radical 53 with radical 53, which is 8 radical 53 over 53. Ugh. It's okay. Secant, adjacent over hypotenuse. At least that's 3 over 8. But cotangent is adjacent over opposite. Our adjacent being 3 again, and a radical 53 shows up. And again, to rationalize, we multiply by radical 53. Radical 53 is 3 radical 53 over 3. And again, 53 doesn't break down, so we don't have to do anything. So just a reminder, you can start playing with the simplification of these functions. Alrighty. You'll notice that we know tangent has been written as other ways. So if we look at tangent, we know tangent is, no, there's two of them, but we'll just kind of eliminate that one. It's sine of theta over cosine of theta. Alright. If we go to cotangent, well, it's the reciprocal of that, which is cosine of theta over sine of theta, or it's actually 1 over tangent of theta. Cosine over sine comes into play. If we look at cosecant, we'll see that as 1 over sine of theta, because it's the reciprocal of sine, and secant is 1 over cosine of theta. Why is this kind of cool? Well, you can start playing with these. So like if you have tangent of theta times the secant of theta, well, tangent we just said is sine of theta over cosine of theta. Well, secant we just talked about to be 1 over cosine of theta, which is then you tops to tops, bottoms to bottoms, because you're multiplying. Well, that's just sine of theta over cosine of theta times cosine of theta. To write this, we write cosine of theta squared. We put it here. We do not write cosine of theta squared, because then it looks like I'm squaring theta. If you did this, now you're in a better spot, but most mathematicians write it that way, so let's not write that. Alright, so round 2. This is, by the way, in terms of sine and cosine, and simplified. Cotangent, let's look at this one, and secant. Well, I know secant has no choice, it's 1 over cosine of theta. Well, cotangent, you can write it as 1 over tangent, and I ain't going to do much, but I write it as cosine of theta over sine of theta. When you multiply, you can cancel out the tops and bottoms, and you get 1 over sine of theta. Theoretically, you could put this as cosecant, but instead we leave it in terms of sine and cosine. Number 3, the secant of theta, I only have one choice, it's 1 over cosine of theta times the cosine of theta. And by the way, it's on the top because it's not reciprocated. Bam! That is 1. And then the last one I have, which is cosecant over cotangent. Well, cosecant is 1 over sine. Cotangent, I could do 1 over tangent, but I'm going to stick to sine and cosine because it said to write in the directions, keep it in terms of sine and cosine. So cotangent is cosine of theta over sine of theta. And we actually get a complex fraction. Deal with a complex fraction, remember you find the LCD at the top and bottom, and multiply through by, which is sine of theta. Technically we're multiplying by 1. Bam! Get 1 over cosine of theta. And that's in simplest form. So those are the basics of trig functions, or the reciprocal trig functions. You could talk more about them in terms of their angles, but we'll do that a little bit later, because right now we're just trying to see what they are and their relationships. So, you have a good day, and I'll see you in class.